Welcome to qnawire.
Hi everyone, so what we have is a constant pressure R134 vapor separation unit, and what we're asked to do is find the flow power if we know the volume flow rate coming into this unit is 6 liters per second at 320 kPa at a quality of x equal to 0.55. We're also asked to solve for the mass flow rate at both outlets. So the first thing we're going to do is state our assumptions. We're going to assume that this is operating at steady state, so conditions will not be changing with time. We're also going to assume that any changes in kinetic energy, potential energy, work, and heat are negligible. So what we're going to do now is define the state. So we know the incoming state is defined by the pressure, that's equal to 320 kPa, and our quality equal to 0.55. What this means is that we're at the saturation state, and we can actually go ahead and solve for specific volume using this information by plugging this into V, saying that V1 is equal to Vf plus X Vfg. And this gives us a specific volume equal to 0.03537 cubic meters per kilogram. Next, what we can do is we can use this information of our specific volume to solve for our mass flow rate, and say that m.1 is equal to v.1, which is the volume flow rate, all over our specific volume, and this gives us a mass flow rate of 0.1696 kilograms per second. Now, we know that our quality is 55%, so therefore for every kilogram of mixture that's processed, 0.55 or 55% of that is 55% of that is vapor. Therefore, what we can say is that m.2, which will be the outlet of our vapor, will be 0.55 times m.1, which gives us an m.2 equal to 0.09329 kilograms per second. The remaining will be liquid, so that means that m.3 will just be 0.45 m.1, and that gives us an m.3 equal to 0.07633 kilograms per second. So these two values are the mass flow rates through our outlet stream. Next, what we're going to do is we're going to calculate the flow power. So we know that flow power is going to be equal to m dot times our enthalpy. So remember that our m dot consists of our vapor and liquid masses. So that's going to be m dot v plus m dot liquid, and our h's are also going to be the enthalpy of liquid plus the enthalpy of vapor. So we know all of these values, and we can actually go ahead and plug this in, and this gives us a total power output, or total flow power required, of 27.7 kilowatts. And that's our final answer.